hypotenuse.
So this is question 21 on vectors. So the question starts off, a particle moves on a smooth horizontal plane. It is initially at point A with the position vector 9 and 7 and has a velocity of -2 meters per second. The particle moves with a constant acceleration of 0.25 I plus 0.3 j meters per second squared for 20 seconds until it reaches the point B. So point B. The unit vectors I and j are directed east and north respectively. So part A is asked to find the velocity of the particle at point B. So we're given the equation of the acceleration, so we can integrate this equation to get velocity. Right, so velocity is equal to the integral of equation of acceleration, which is 0.25 I plus 0.3 j, right, dt. So our velocity is equal to 0.25 t I plus 0.3 tj plus c. However, we're given c in the question, as it says it's initially at point A and has a velocity of -2i and +2j. So we can plug that into our equation. Get v is equal to 0.25 t minus 2 all of I plus 0.3 t plus 2, and that's all of j. Okay, and now we want to find the velocity of the particle at point B. We read over the question. It says for 20 seconds until it reaches point B. So now we can plug in 20 seconds into our equation of velocity. So once we plug it in, we'll get a value of I is equal to 3, and we'll get a j is equal to 8. Right, so we get 3/8 meters per second. So that's part A. Moving on to part B now. It says find the velocity of the particle when it's traveling due north. So what does this mean? Okay. So what this means is, right, you got your compass, you got north, west, east, and south. And due north means that it's only going in the north direction. Right. If it's only going in the north direction, that means there's no x direction. Right. It's only going up towards north. And it can't be south either. So that means we must have a positive north direction. This means we must have a positive y. We must have a positive y. Or in this case, because we're doing vectors, we have positive j. Okay? So if we look at the equation, the question asks find the velocity of the particle that's traveling due north. Now, previous question, we already found the equation of velocity. So now, using this information, knowing that it cannot be any x, or it can't be any I, there only must be a positive j, we know that the x coordinate, let me rewrite our equation. Let's rewrite it into an easier form to look at. 0.25 t minus 2, 0.3 t plus 2. And this is our x, and this is our y. If it's due north, we cannot have any x. So x should be equal to 0. We can equate that, our equation is equal to 0 to find our time. We get t is equal to 8 seconds. Now that we've found this, we can check our y equation, because we want to find our velocity, right? And based on our equation, you can tell that y is only going to be positive because t can only be a positive number. So no matter what value of t you put in, it will always be positive. So this shows that it does follow our compass diagram that we just drew. Right? It will only be a positive north direction. We plug that in to get v is equal to, so we've got 0 up top, and we plug in 8 times 0.3 plus 2, and that will give us 4.4. So that's our velocity. The next part, part C, is to find the position vector of B. So what's this asking for? Is you find the displacement of B. Okay. And we know that if we integrate our velocity equation, it will give us the displacement. So r is equal to, this is displacement, the integral of v dt. We got our equation of velocity up there. Right. So we got to integrate this. I'll do this in a different color. We'll integrate the equation of velocity. This will give us 0.125 t minus 2t, and this is all of I, plus 0.15 t plus 2t, this is all j, we've got plus d. Let's look back in the question. The question states that it's initially at point A with a position of 9i and 7j. So it gives us our value of d, which we can plug in. So our equation would look like, so we can plug in 9i plus, was it 7j? 7j as our d value here. So, and we look at the equation again, and it says at 20 seconds it will reach B. So now you plug in 20, we plug in t is equal to 20 for all of our t's in our displacement equation. And once you've plugged that all in, you'll get r is equal to 19 over 107. Okay. The final bit of the question says, find the average velocity of a particle as it moves from A to B. So average velocity is equal to displacement over time. Right, I'm giving time is equal to 20, and the displacement from A to B is equal to B minus A by rules of vectors. And we found a B in the previous question as 19 and 107. So we got 19, 107 subtracted by A, which was given in the equation in the question, 9 and 7. This would give us 10 and 100. And now we've got to divide our displacement. This is our displacement. We divide our displacement by 20. This will give us 0.5 and 5 as our average velocity. Make sure you put the units. And yeah, then you're done.